Right, okay, for the people who weren't here the other day, I'm just going to go through quickly the internal structure of a leaf. Just you know what kind of talk about, and it makes more sense for the questions. So on here you can see you've got internal structure of the leaf, and there's your two learning objectives. The top one is probably more, we'll cover more of that, and then the bottom one you probably have a little bit of an understanding of where carbon dioxide and oxygen come from in terms of their waste products and metabolism, because obviously carbon dioxide is going to come from respiration because plants still carry out respiration, and oxygen is made in photosynthesis. They're both waste products of metabolism. Obviously, carbon dioxide will be used in photosynthesis, and the oxygen will be made by photosynthesis, but then used up in respiration. So, what we're looking at there is how a leaf is structured to carry out photosynthesis. And you probably never thought, I mean, if you had like, if you looked at a cross section of a leaf, like if we cut a leaf in half, you probably just think of a leaf as just being there, but it's obviously made up of lots of different cells. It's very thin. It's got a big surface area, and it's trying to maximize as much light uptake as possible. It's got different features that allow it to do that. So you'll see at the top, it's got a little cuticle, and this cuticle is waxy. So it's a waxy cuticle. And what that does is it prevents any water being lost from the top because the water can't get through that layer. So it's kind of impenetrable to water. And also water, when it comes along, will drain off. Also protects it from microbes as well, so bacteria can't get in. You have this upper epidermis, which is like a skin layer. You have an epidermis, which is your skin, and like a little layer here, which is transparent. Same with the bottom one. But the top one is going to allow light through. Now, the kind of engine where all the factory, where all the photosynthesis is going to happen is this palisade layer, which is made of these long, thin cells, which are really, really packed together. These are packed full of chloroplasts as well. So when the light is shining through here, you've got to think of this as a 3D structure going all the way across the leaf. They're going to be absorbing as much light as possible, taking in as much energy as possible, and these little chloroplasts here are going to be carrying out photosynthesis and making as much sugar as possible within the plant. So that's why you have that palisade layer. But then you've got to think, if we go back to the equation of photosynthesis, we need carbon dioxide and we need water. So we've got to think, how are we going to get it there? So down here, you have these xylem vessels, which are in here. This whole thing's called the vascular bundle, and that's involved in transport. So this brings water up from the roots to the leaf, but it also takes sugars away where they're needed, maybe to the fruits or anywhere else in the in the plant that needs those sugars. So the water is going to come over the xylem, and then it's going to get to the palisade cells, so that then they can carry out photosynthesis. And then we've got to get in the carbon dioxide. So within the plant, you've got your hole at the bottom here. You probably can't see it too well, but I should have taken this down. I wonder if I can just move it for you. So you do have the guard cells, and what the guard cells do is they are in control of this hole here called the stoma. You have more than one, it's called stomata. So this is where the gas exchange is going to happen. So carbon dioxide is going to come in here, and it's going to go to the palisade layer, and that's going to be used up in photosynthesis. Now, if you think back to year 9, and beginning this year as well, we talked about diffusion. So diffusion is where things go from a high concentration to a low concentration. So because all that carbon dioxide keeps on being used up, then more carbon dioxide is going to diffuse in. So you've got a concentration gradient. It's also it's not very far for it to travel, because remember, this leaf is very thin. So that carbon dioxide doesn't have far to travel, so you're increasing diffusion as well, because there's certain factors that will increase diffusion. One's temperature, obviously a short diffusion pathway, and a big concentration gradient. So if all the carbon dioxide is being used up, then it's going to move in. The oxygen, in the meantime, is going to be being produced. That is a waste product of photosynthesis, so that's going to travel out of the stoma, and that is obviously high concentration here, low concentration here, so it's going to move out of the leaf. If the leaf is also carrying out respiration, some of that oxygen will be used up in there. But this is what we call the spongy layer, because it's got loads of air spaces, so the air can diffuse through. So you can see there's a difference in the cells. These are all pushed together, really packed tightly. These are really like plenty of airspace, so the gases can circulate. And you have your stoma here, your guard cells, and these control whether this is open or not. So rather like in your eyes, you've got the iris, which controls the size of the pupil. Here you've got guard cells, which control the size of the stoma. And then you've got your lower epidermis here. So like on the next slide, it kind of shows you all that. So if you want to stop, pause, whatever, you can come back to this at any time. And then I've just got other examples of the structure of a leaf. So like, there's no diagram of a leaf, so you can see the vascular bundle, palisade layer, lots of air spaces here, stoma here, the guard cells either side, you've got like a stomata on top. Generally, you don't get them on the top because you'd lose too much water from the plant, and that's not a great diagram, to be honest. But that's just like an introduction to the structure relief. Hope you're doing okay, guys, and hope that was useful. Thank you.